Hi again. My name is Amit Pundir. I'm a senior software engineer in Linaro. My primary role is AOSP bring up and maintenance on embedded devices. You can catch me on IRC as Pundir on AOSP developers at oft.net. In this session, I will provide an overview of the different development boards supported by Linaro in AOSP, the level of testing that is performed, and the benefits and pain points of supporting these Devboards in AOSP. I'll start with a quick run through the slides on the Devboards that we as in Linaro support in AOSP. This is not a marketing thing, just a short summary of who we are, what we do, and why do we care about Devboards in AOSP, in case you are not already familiar with what we do. So Linaro supports a variety of member development boards in AOSP. These Devboards are chosen based on a number of factors, including popularity, device availability, upstream support, and most importantly, how relevant they are in the AOSP ecosystem. Linaro provides latest software update for these Devboards. By software update, I mean the latest AOSP builds, ensuring that the latest version of Android operating system can be installed and run on them, with the latest LTS kernel versions if possible. And to ensure that the Android operating system runs smoothly and efficiently on these Devboards, Linaro performs extensive testing coverage on each board. This testing includes both functional and performance testing, as well as CTS, VTS compatibility test suites to ensure that the Devboard meets the compatibility definition document requirements. Again, I can't stress enough on the extensive testing that we do on our supported Devboards. You can take a look at this LKFT metrics link, which I have provided. And this is just a snapshot of the test metrics that we prepared at around the same time last year for the testing coverage on the Qualcomm Dragon boards. So these are just two Devboards I'm talking about. I just copied the slide as is. I hope I'll do better next time and give you up-to-date numbers. The number of kernel versions and upstream user space builds being supported have only gone up with Android 14 6.1 kernel and Android 13 GSI. Again, the next set of slides regarding the Devboards are shamelessly lifted from a similar talk we gave almost a couple of years ago. That talk was on a slightly different track, highlighting the importance and benefits of upstreaming your devices. You can check out the complete talk here. I have only lifted the Devboard specifications and release timeline. All right, so it started with HiKey in 2015-16 timeframe. HiKey is based on high silicon Kirin 620 SoC. It had modest specs, but lost its relevance soon because of the rising AOSP requirements. Dependency on out-of-tree Mali driver and tightly coupled dependency on Mali binary blobs did not help either. This device is retired from AOSP, but it is still possible to boot AOSP on this device if you can get Mali driver to build, of course. HiKey 960 filled the HiKey void over the time. It is based on the high silicon Kirin 960 and still actively being tested in Linaro. But it suffers from the same proprietary Mali issues like original HiKey had. Next up is Beagle board X15. Features are not actively being worked upon on this device as such, but this is supported nevertheless to keep 32-bit AOSP build testing going on. Next is Dragon Board 845C or RB3, which got merged at around the same time as X15. It is based on Qualcomm 845 SoC, as in Pixel 3 or OnePlus 6. It was the first Qualcomm Dragon board in AOSP after earlier attempts to upstream as if I can say, upstream the Dragon Board 410 and Dragon Board 820 in AOSP. As of today, all the features are fully upstream. It runs open graphics, Mesa. It can also run a software rendering stack using Swift Shader. We are actively working on this device. The other device which we are actively working on and fully supported in AOSP, if I can say, is the Qualcomm Robotics Board RB5. This one is still the latest and most powerful SoC that we support in AOSP. It is based on Qualcomm SM8250 SoC. Think of OnePlus 8 and similar devices. It is a successor of DB845C, the Dragon Board 845C. Again, the slides are a bit old, but this device is now fully supported in AOSP with latest boot image header version, which is 4. Few key features are still work in progress though. The good thing is that both RB5 and DB845C are almost feature comparable, and we provide a unified build for them. So it is possible to download or build DB845C user debug, which is a AOSP builder target for DB845C, and you can flash it and boot it on both DB845C and RB5 devices. Honorary mention goes to Qualcomm SM84550, which is supported in AOSP if you look into device Linaro Dragon Board project, but it boots only to ADB console. Plan is to revive and enhance its support once we have enough number of these devices out into the hands of developers, including us. With all these dev boards in AOSP and other few in pipeline, the question which often comes up is why do we value dev boards in AOSP? What value does it bring to us or Linaro? I listed down a few points, but the simple answer to that is that it kind of creates an overlap of the upstream kernel development or any upstream project which we use on any particular device. For example, I can give you an example of Dragon Boards where we use open graphics Mesa stack. So we actively test, report, and fix regressions on Linux kernel and upstream Mesa. And that allows developers to catch and fix regressions and help them upstream with more confidence. So I'm talking about the in-house developers, sorry. It also helps us develop and prototype latest AOSP features and technologies. I've listed down a few examples of what we have done with that. For example, this GKI prototyping. So while GKI was still a work in progress and we were actively following it up on Android Garret. And we picked up the patches and we started doing it and we started converting our drivers, making them more GKI compliant. And I think we were very early adopters of running a GKI kernel on a production device on Poco F1 at that time. We already had it working on DB845C, so that helped. But running it on an actual production was something else. We did not actually expect that to work that easily. Similarly, DMA buff heaps transition, we helped develop and prototype it on Dragon Boards or HiKeys. Development of generic HALs using the modern upstream kernel interfaces. One quick example of that is that if you work with downstream Android devices, you see that the haptics driver is implemented as a LED driver. It's not an input driver. While upstream Linux kernel, it develops it as an input driver. So we, instead of LED driver, we started using it as not using it, but we started developing it as a input driver. If you follow AOSP developers, so there is an AOSP developer IRC channel where a couple of like-minded developers hang out. Caleb actually did that. Caleb implemented this. He did the transition from using LED driver to input driver for his haptics driver, which he was developing. And we have that working on Poco F1 and OnePlus 6 and a couple of more SDM 845 devices. So now maintaining a Devboard in AOSP is as tricky as maintaining any other Linux distro on a Devboard. But what makes it more difficult is that there are a lot of moving pieces in between. Because remember, we are not talking about maintaining or running Android release tag or branch on a Devboard. We are talking about AOSP, which churns out changes like hundreds of patches almost every day. And if there is a build or boot breakage, personally, I don't even try to bisect it unless it keeps bothering me for a couple of days. Because most of the common or usual breakages are transient and waiting for a relevant fix to get merged, and they just wait for a relevant fix to get merged in another project. And sometimes you just happen to get stuck in that sync time frame. Other more serious issues include upstream breakages, be it, from my experience, it's mostly Linux kernel or Mesa or the open graphics stack, right? The DRM hardware composer, libdrm. Sometimes even AOSP. Yes. When they do a transition from, for example, right now they are transitioning from HIDL to AIDL. So most of the features who are still not fully AIDL compliant, sometimes they just fail, that particular feature just fails to run. So yeah, so these are the few breakages that I can think of right now. Another thing which we keep on chasing is keeping up with AOSP requirements. For example, boot image header versions. If you follow that bootloader space, then you know that almost they have jumped from default boot header version to like boot header version 4 in a span of 3, 4, or I think 5 or 6 years. So it's very difficult to keep track of it, and getting it implemented at a bootloader level is a bit tricky because most of the bootloaders are not open. And even if they're open, they are just meant for one particular device or one particular release. So you are either on your own, or if you are lucky to have a Qualcomm device, then you can look around the Linaro code base for different device bootloader versions and see if any of those devices have implemented that particular feature, and if you can backport that feature easily. At times, we do need to update external projects as well to support a feature which got recently added in that particular external project. Again, from my experience, I'm still talking about the graphics stack here, but it could be any other project, depending on what kind of project you are using on your device. Some activities are planned based on the device limitations. For example, AOSP bring upon early silicon devices. So at times we start with ADB only config, and then gradually move up to bring up display with software rendering before integrating hardware accelerated graphics support. So this is where SM8450 is right now. It's not fully supported in Mesa yet. At least last time when I checked, it is not supported in Mesa yet. So our plan is to have software rendering display working on it, because its display driver, the DRM KMS driver, is already upstreamed. So if I can just use upstream driver and use software rendering, then it is possible to boot AOSP to UI with software rendering display. So these are a few points that I could sum up in this short slides of mine. I hope these are useful. Let me know if you have any questions around these.
Cool. Yes. Thank you very much, Amit. That's great. Yeah. So I guess the question that comes to my mind is, how does the relationship, how does the integration with Google work? Since you don't have, I imagine, direct commit rights on the Android development tree. So I guess you have to have somebody within Google to help you do the commits and the code reviews and such.
So even we don't have any direct contacts within Google who can just, we can just directly ping. So what we do is, based on the commit history, we add the reviewers that, okay, so this guy has already merged so many commits before, or he has so many commits already in this project. So he may be able to review the patch or add any other relevant developer who can help us review the patch.
Okay, but you have to have some relationship with the Google developers to be able to do this, I guess, because I guess if I were to come along and submit some patches to Gerrit, yeah, go.
You have to have the contribution agreement signed and uploaded. It has nothing to do with Linaro's partnership with Google. Even an independent developer can do that. You just open the Android review.android. Sorry, that link is a bit hazy in my mind. But if you go to Android Google Gerrit with your personal Gmail ID, then there is an option to sign the CLA, the contribution licensing agreement or something like that. And they will review it in a couple of days and they will give you the upload access. So this is a patch upload access. So you can upload your fix against a particular project. Not a particular project, against any project in AOSP.
Okay, cool.
So once you have that, then you can add. Again, you can go to the commit history of that particular project and check who is the more active developer in that project and add him as a reviewer, him or her as a reviewer.
Okay, cool.
Anybody else? So what bootloader do you have on the Qualcomm platforms? It's not U-boot, right? It's something else.
So it's called ABL, Android Bootloader. It's a EDK2 spin-off. So it's not exactly UFI. It's a.
Okay.
And I'm really sorry about the noise quality from my end, because when I hear your questions, I can see that how I am sounding to you guys. I'm really sorry about that.
Sure, it's okay. It's at least I can cope with it. I hope everybody else can.
Yes. Can I also ask a question?
Yeah, please do. Yes, go ahead.
Yeah, hello. Thank you for the talk. So I actually have two. The first one, I see that if I open Android code search, there is a device Linaro folder, which I assume is what you're responsible for, right? So this is kind of continuation of what Chris was asking. So how close this folder to your, let's say, to your repository? So is it being picked up really regularly, or it's like it's half a year behind what you're working on? Right? So how often do you upload? And if it's is it limited to this folder device Linaro, or you just some other places too?
So these device Linaro projects are the projects we are actively working on. So there is nothing hidden on my desk which I have not uploaded yet. So all the changes, all the patches which we work, all the features which we work on, we push directly to device Linaro Dragon Board or device Linaro HiKey projects.
Okay, great. So basically, you do have permissions for that. Okay, and the second permissions.
So we have permissions. Sorry, we have permissions to upload the patch, right? So even you can do that.
Yeah. So
the only caveat here is that when we started with this project, we needed a helping hand from within Google to create that project. Because if you see the device Linaro Dragonboard or device Linaro HiKey or any project of your choice, external developers do not have access to create these projects. Once these projects are there, you can upload your patch or you can submit any fix you want. Yes, it is Google's carrot.
Yeah, I understand. So the second question is like on the other end, and how you work with OEM ODMs. So basically with Qualcomm, with HiKey. So with these guys, do they provide you with like a vendor folder? Do you create it yourselves? And if I want to get it for, let's say, HiKey, I assume there is like a vendor folder, right? Which I need to build AOSP.
Right. So in case of HiKey, I don't think any of the binary blobs are in Linux firmware project. So Linux firmware project is an upstream project, upstream firmware project where binaries are kept, or these SoC manufacturers, they upload their binaries. So I don't think HiKeys or HiKey 960 have any binaries uploaded there. But in case of Dragonboard 845C and Robotics RB5, all your binaries are there. Your FreeReno graphics binaries are there. Your Wi-Fi and Bluetooth, pretty much all the binaries which you need to have those features enabled on these devices, they are already on Linux firmware .get project. So just in case if you are not aware of this particular project. So we directly copy these firmware binaries from that project. But if you see the vendor project which we use, we also publish bootloader binaries, which come from Linaro. So we have some sort of a distribution licensing agreement with Qualcomm. So we can reshare Android bootloader and other binaries, pre-boot binaries. So I think it's like a mix bag here. So we have the early boot binaries are not open; they are not redistributable. I mean, if you are downloading it from Linaro, if you are using our AOSP builds, then you can use it or reshare it. But if you are downloading it or copying it from any other source, then I'm not really sure if you can redistribute it. So it is similar to, for example, we also work on booting AOSP or running AOSP on form factor devices. So we have a nice little sort of non-active right now, the project where we have pushed STM845 based phone support running AOSP. I can share that link if that makes it easier. So you can build AOSP for Poco F1 and OnePlus X and Swift MQ phones, and people have used those particular repositories and projects for other non-STM845 phones as well. So we share the common infrastructure, common build folders, and common projects, but we don't share the binaries because talking in lawyer terms, we do not have. I cannot share my Poco F1 binaries with anyone else openly. Right. So
Okay,
That's
so
different than the. Sorry.
I just wanted to ask, so if I, for example, I buy one of the boards, like HiKey or Devboard or something, is there like one repo manifest or something that just allows me to download the full full folder structure? So the full AOSP, the full code with Android, and just build it, or I need to piecemeal go to different companies? Like
no. So the devices which I talked about, they are fully supported upstream as in AOSP. So if you download AOSP source code, you already have the support for HiKey, HiKey 960, and Devboards. You don't have the binaries yet. So when you try to build for DB845C, for example, it will tell you to run the little script, and it will download all the binary blobs for you.
Okay, understood. Thank you.
So just a single manifest, it will build you, but without binary blobs. So this binary blobs, keeping these binary blobs out of AOSP is a new requirement because Google did not want to deal with different binary blobs and licenses. So this is not a recent change, but we moved to external vendor package, I think. Yes, last year, January or December, maybe, I think.
Cool.
Before that, if you do a AOSP sync, then it will download everything. For example, if you download Android 12 GSI, then if you sync Android 12 GSI, then I think it will download the binaries as well. I may be wrong, I may have to check, but I think it is possible.
Okay. So we're kind of out of time on this slot now, but thank you very much, Amit. That is fascinating stuff. And yeah, I keep up the good work is the first thing I'd like to say, both you and Linaro in general, and also Bay Libra, who I noticed Matthias is on the call as well. So Bay Libra also support a bunch of, well, several boards in the AOSP. And we need more of them. It's good to have some references.
Just to be fair, I'm not as actively working on AOSP master as Amit is, so his talk was very interesting to me as well.
Cool, absolutely. Excellent. Just one thing. Sorry, I can't resist asking this. So who is supporting the TI X15 board? Is that Linaro?
So it started as a Linaro project because at that time TI was still an active member of Linaro, and their membership ended, I think, last year or year before that. But we are not developing any new feature on X15. We just make sure that it builds and we can run CTS, VTS, and other tests in our lab. So we still actively test those devices.
Do you know if anybody's working on the latest TI chip, the 62XX chips that's in the Beagle Play? Is Linaro or Bay Libra or anyone else working on that?
I'm sorry, I know that Bay Libra did. Yeah, sorry.
But it's not part of AOSP, but we are working on it, yes.
Ah, okay. So you have board support, but outside of AOSP.
Yeah.
Okay, cool. Good to know.
TI has their own hosted manifest with some forks and some additional projects to have it built and boot on their Devboards.
Okay, I should check that out. I was trying to get my hands on a Beagle Play. Didn't quite get around to it yet. Okay, thank you very much, Amit, and everyone else.